All right, that works. That math is fine. Is right. Ooh, because I'm happy. So that math is right. Then there's something else that we're doing wrong. No, almost. The math is good, right? However, um, we don't actually see the entire website, right? Like the buffer that we're using, this buffer, doesn't actually get all the contents in here. And I don't know if I'm missing something in the reads, right? So maybe we can just read that out, right? IO buffer to string buff and you know what? I think the problem is that we are actually starting from scratch on every read here. If that's right, then we should actually see all the contents on every iteration, right? Exactly. We only return the last one. So this is the last one, right? Yeah, header is close here, so this is definitely the last one. And yeah, this is the last one, exactly. Promise to have, can nothing, and here's the rest. And there's more ahead. Give me the hand. I don't know the lyrics, but this is so fun to try to sing along. Okay, so we do read, and we give a buffer, and our buffer is pretty big, right? So what we want to do is check how the hell we are reading, because I feel like we're reading from the beginning of the buffer every time, and maybe we should be offsetting that buffer. So, damn the allergies. In other words, we read this many bytes, and we should do something like IO buffer, right? Consume buff length. So this it's called consume, probably a bad name. We're just saying like, okay, we're gonna move the current position of the buffer a little bit, right, to the right, and that this probably means, right, we want to be careful of how we write the next time. How the hell do we do that? That's not gonna be enough, right? Yeah, that makes sense. Because this reader is going through to reader right here, which is using this read, right? So we're setting the field amount. And I guess this will be field plus field, right? I mean, not there, but you get it. Um, and it will also depend on how we're actually writing. So if we go back to the network, when we do receive, right, we're passing the C struct here. But we have not modified the offset. So I think we should probably, when we do add C struct, right, we should actually do C struct sub, right? and then we do T. First, we need the length. First is the offset. So we need to keep this inner C struct in sync, right, with our buffer state. That way, when you say, "Oh, I want the C struct version of this," then we respect, right, the other variables in here that are being used for reading and writing. And at this point, I think position would be the good offset. It's like you already have read, actually, filled would be the best offset. And the length will just be the inner dot length. Do build. Let's see if the test passed still. Woof! Breaking everywhere. Or maybe we want to modify the offset as we go along instead of all at once. Like the inner off. It might actually be a good idea to just use that, right? They don't expose that. como un océano, como un mar. Una eternidad. Y esperé ese instante. Okay, small refactor here. Some things should break, but not too big, too much. Of big array. Tómate el tiempo en desmenuzarme. In the C struct contain the B starting and offset off, default 0 and length. Wait, you're saying that we have defaults for this? What in the hell? Seriously. Que mata. offset and length cannot be the same. Unexpected input, right? In the IO reader test. Hello world, that's 8. And we had capacity 10. We're gonna put the bytes there in the capacity. Easier to read when something goes wrong. Cool. So capacity 10, unexpected test. Okay. Hello wall, and then we say he again. That seems so wrong. Like we're not really playing with the buffer. Okay. I think we're gonna need to do that refactor at some point and get rid of this struct internally. But for the time being, let's go back to what we had running, which is mostly right. So this passes all tests. And now our problem is that if we go into test fixtures, right, and we write a really large file, so we get a website like OCaml.org, right? Nope. Right, 58 kilobytes. Then we can actually have a test here. Instead of reading the fixtures, we can read OCaml.org, right, HTML. And we expect it to fail because, it's just, it is asserting something different, right? But that is, so maybe we leave that one as is, right? And we'll make a new test. Reader large test. Test tune. Make another one there. And now we're gonna change that. Probably don't wanna try different buffers. Or maybe we do, I don't know. We'll see. OCaml.org, HTML. We know that that's gonna be 57 kilobytes. 57946, right? And that's kind of the buffer that we create, right? Small problem I think would be that we're using the file reader here, not the socket reader. But if this fails in the same way, then at least we know that it's a problem with the reader itself. Okay. Capacity 4, remove that. We don't want the buffer reader. So we expect the first one to, I think this is just reading the whole thing. But we're still coming out empty-handed in the string, right? Why? Yeah, it's not very good. Why? Hey, Dylan, how's it going? We got really far, dude. Look, this is the HTTP, like TLS decoded, right? HTTP responses from trying to fetch a website. We just have a bug in the reader here, because this thing is sort of assuming that this buffer is throwaway, and it shouldn't be. Like, it should be like, all right, we'll just keep offsetting into the same buffer until it's full, right? I think. I don't know if Felipe is around. I don't think so, because he lives in Sweden and it's fucking 5:30 in the morning, so he's probably asleep. But I think he would know. I mean, the question here would be like, what would the right behavior be, right? Maybe we should just look into Rust and see how they do it. No, what do I want to blink? There you go. And then we go into EIO, and we don't need it for that. and then we go into, what's this? More AIO, and then we go into Rust. So how did they define read line? Breaking down. Got it, early days. Yep. I love how people are using this as a meme. It's pretty amazing. Shout out to Pontus, who is hilarious and right now could use some energies. What song is this? Oh yeah, someone comment, someone comment. Sleeping Sickness. Have you listened to City and Color, Dylan? I think that if you like Ren, you like this. Like the singing thing style is very very different, but I feel they're on the same side of of the music spectrum, or maybe not side, but like quadrant or octet or something. I think his name is like Dallas something. Dallas Green. I don't know who else is singing here, but there is somebody else for sure. Really, tragically hip. Ryan, are you Canadian? Ah, that's why I like you so much. Cool. Love Canada, man. All right, so I have read line here, and that is implemented in terms of read, I believe. Yeah, look at this. Gorgeous. So if you implement read, which will be somewhere here, right? There you go. And this is the thing we implemented, but let's see how it should behave, right? Pull some bytes from this source into the specified buffer, returning how many bytes were read. The function does not provide any guarantees of whether it blocks writing for data, but if an object needs to block for a read and cannot, it is typically a signal via an error. If the return value of this method is okay, and you get a number, then implementation must guarantee that 0 buff length. A non-zero n value indicates that the buffer buff has been filled in with n bytes of data from the source. Huh. If n is 0, then it can indicate one of two scenarios. Yep. Yeah. Meow, meow, meow. Yes, exactly. Oh, dogs, people. They are amazing. One of the things I love the most about Rust is that people understand the value of having this kind of documentation. And we're looking at a trait deep into, right, the, the standard library. Even for modules that are plain obscure, right? Like somewhere in here we had buffer, a buffer type, right? Inside of, I believe it's like buff reader, yeah. And I don't know if anybody uses this buffer because this is part of like the standard library buff reader. Yeah, I think so. I really enjoy like I enjoy a lot about the Rust docs that they are thorough, right? They have a lot of, but they're not sort of too dense in style. They're not too formal in style, right? But they have a lot of information, and a lot of it is written in a very approachable style. Like, hey, look, take care of this thing, or if this happens, then worry about these scenarios and stuff like that, right? What I enjoy about the Elixir docs is that they're usually pretty like this is how you can use this thing. Especially around Phoenix, for example, is all about like here's the use case, go for it, right? Sometimes that means that if you're looking through Rust packages, sometimes you have to read a lot about how it works before you figure out how to use it. Um, on the other hand, I feel like Elixir has the opposite problem, right? Like there's a lot of stuff that is just undocumented how something does work or should work internally. You just get a recipe for how to use it, which is great if you just want to use it. But yeah, okay. So what we're looking for here is whether this method should write from the beginning of the buffer, and I think that is the right behavior. Yeah, actually, I think there's nothing broken. In the examples, even in the examples, right, it's just saying like, all right, if you want to read 10 bytes, you give us a buffer of 10 bytes. I see there's something, what, IO read v test? Oh wait, IO read their large test. There you go. Yeah. Right. I don't think one is better than the other. It's just it depends on what you're trying to do. Come on, we can make this happen. We're trying to read that many bytes into this buffer. So if we do 46 with capacity and we read, all right, we had to do the IO buffer. Set field, right? Buff len. What are you talking about? It is right here. Field. Never mind, that's on me. So when we read into that C struct, we actually need to say we moved this much. I don't really like that. But if we want to get rid of the C struct ourselves, we're gonna need to rewrite some C code. My God, there is so much cat hair, so much. All right, we have most of the file here. Let's see if it ends correctly. Yeah, it does. So why are you complaining? Line 29. Oh, right. We're never going to have that file there. Crap. I think we could just do string length here. Oh, come on, just length. There you go. Final string. It should be 57946, right? Okay, cool. Now the big example works because we fixed that thing, but the other ones are broken. IO writer test. What is the problem here? IO reader test. Let's start with that one. That's the one that we see here. Capacity 8. We're trying to read up to 8 bytes. That's fine, right? We're going to go from debugging to trace. We're never updating the position. Why are we not updating the position? Did we change something in the buffer? Set field. Ooh, great song. I do, brother. Just keep shading. So, okay. Here begins the second test with a buffer capacity of 7. We read 7 bytes, we get there, perfect, right? And we have to choose how much to put there, which is great. And so we are, I think the problem was when we updated consume, didn't we? Did we update consume or filled? Because we're calling fill buff, we fill the buffer, that's fine. We get a first readout with 7 bytes, beautiful, perfect, right? Now that buffer is a throwaway, so we don't care about it. Now we read capacity again, right, which is here. And capacity is 7, position field 0, perfect. We read 5 bytes in, perfect. We're not still full, so we try to read again. And we read 0, which means there's nothing more to read, right? As opposed to, wait. And, well, that sucks. Because when we read the second time, we're fill buff, right? Why do we do that? Oh, okay. So if the file now is setting the field, right? then set field must be the old field plus the offset that we have now. And I think that will track. So now the test is failing, I think is the big one. And we see the text because we have read this text, right? I just think that maybe the truncated by doing that's fine. Maybe the IRE large, right? The number is different. 5794. Like that's the only reason that we would go into the other position, right? So let's do this. So we can see how much, what is the actual expected input. Unexpected. 4. Seriously. The expected input is 4? How? What did we do? Oh, no, sorry. I misread that. This is the expected input. That doesn't seem right. And I think it makes sense because we read everything at once, right, on the first one. And then we read it again. So I guess this one divided by 3 will be the number that we had there, 5792. Okay. So essentially, we don't really need this stuff here. But it's good to know that if you read it again, then it will read it again. I don't know if that's right behavior. We can look into Rust as well and say. F and main. Grab that stuff here, right? Read 10 bytes, and then we'll do buffer 1, and what we want to see if it behaves this way. M. Two different data structures, right? Retest. Okay, so it doesn't behave the way we thought. It consumes, it fills the buffer, that's fine. So the buffer is a throwaway, but the source is not, right? So we need to move the position as well. In other words, the file here will say that this is field, but it should also say that the buffer, no, the buffer is fine there. But whenever we call somewhere that I'm yet to find out, we need to advance this thing. 1 second. Buffer set field. Buff field len. That would actually fix some of the bugs. I wish I could do better by. Your life. So the right behavior for that test would be that this, right, and this return 0. So the last two strings are empty because we've consumed the file reader. So when we call IO reader, right, and we do read like that, that has nothing to do with the buffer. Ooh. But it has everything to do with the file. Because we're running this code over and over again, right? And I bet that if we go into the file implementation for read here, we will see an operation like seek or something like that. Solid, was it solid IO? Solid FS, yeah. File. This is the file implement read. Okay, so maybe implement file. ABI solid ABI FS. And let's copy that symbol. We need to search it here. I feel a dying complications do the things that I left undone. Without my cane, who's a master of none, solid FSH. No. Okay, you know what? Let's search for that. So we need a solid FS read. Some life just ain't that hard. Classic dad thing to say. Rust Solid ABI. Let's see what the hell is that, because I didn't know about that at all. I'm not entirely sure where that is defined, but I see a little call to read here, right? In the file, in what's essentially the implementation on a FS file, right? Which is from here. Ooh, I guess I take after my mother. So maybe that's not the right one. Maybe we are on macOS somewhere. If Unix, actually maybe it's Unix. Get a file, so if we do implement file, then that should go into impl file descriptor, which where the hell do they come from? File desk. Okay, so fdrs, fn read. So this is a libc call to read, and I don't know if this does seek for us, but maybe it does, and the problem is that we're not actually doing the seek. What the hell is CVT? I guess fun CVT. All right, cool. So Unix mod CVT. What are you? Oh, this is sort of wrapping. Okay, this is extracting the error. Okay, cool. Useless for us, but cool. So function read. We're just calling into libc read. So let's ask the GPT. Chat GPT. Will libc read on a file actually seek into the file descriptor, or do I have to seek manually? Okay. So that's confusing to me. Because I expected that call to read to actually do something like that. So again, if we go into a standard FS, right, and we're going to implement read for file, then we get this one, which is the call that we're making, right? And then we can do inner, and the inner is going to be an FS, one of those. And if we go up, that's coming from sys. So if we go into sys, right, FS, we have a bunch of those. Hermit, solid, I don't know which one is the right one, but I think they should all behave the same, right? And Unix would be the one that I think is closest to what we're trying to do here. Yeah, okay. So this is, if it's considering macOS for this field, then this stuff must definitely be part of that. And if we go into the implementation here of function read, right? We have two functions, one in open options and the other one in file. And the one in file is just calling 0 read. And struct file has a file descriptor inside, which comes from, in this case, right, FDRS Unix here. And this file descriptor, right, has a read function, and this stuff is calling libc read. Are you sure that libc read does not seek? Oof. You know what? Let's try that. So it moves the offset I'm reading from, or if I call, I think it just told me that, 10. Son of, okay, so it is doing, I mean, it's not seeking specifically, but it's offsetting us, and that makes perfect sense because we're not doing that. When we call readv, right, we go into our POSIX stubs and readv, doesn't do that. Sometimes when I ask again, they're like, "I apologize, that's not correct." Yeah, right, and like that's usually the behavior. Like when you go, "Are you sure?" They go like, "Nope," immediately backs down, right? But in this case, he was like, "Nope, I'm right." I guess there's enough dogs around seeing the planet. Yeah. Yes, I can confirm. Okay, so I think I think maybe we're not. We assumed that this was doing what we expected it to do, but it is not. Odd, odd, odd. So repo, we want to go into OCaml multi-core, yeah, yeah, and then we'll go into POSIX stubs. Actually, not even that. We want to go into low level in POSIX, and here there is a call to read B, EIO read B, do non-blocking. Ba-da-da-dum. Hoo, 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 hoo. Period. Bum, bum. Oh, this is a good one. Dum, dum, dum. So there goes my life, passing by every. I mean, instead of asking GPT, we should just read the docs. RTFM. Read from the specified position of the file. We don't modify any file pointer. So it's pread and preadv, and we're using read and readv. An object capable of seeking and read startup position given by the pointer associated with files. Upon return from read, the pointer is incremented by number of files actually read. Bum, ba, bum, ba, ba. Okay, so set field is doing the right thing in saying that we're just gonna set field to whatever you're saying because you wrote from 0, right, into that buffer. So every time you read into the buffer, you start reading at 0. And I think that makes sense. So this would be a field. Test will break, that's fine. But when we do that, we actually pass the large read test, we fail the small reader test. Every deep bottom fight. I think it's easier to fix this one. Or rather, this is the one that's broken. So we go into read capacity 7. We read 7 bytes in there. Excellent, right? We try to copy. We only have 70 copies, so we copy 7. And that's what we flush out. So far, so good, right? Now, what happens afterwards is that we have a new buffer, or the same buffer, we don't care. And we read 5, and then it's not full, so we try to read again. And then we read 0, which means we're done, right? But at that point, we call field buff. And field buff is resetting the buffer, right? So here's 5, right? We read. And then we go again, and we are here at the top, right? And then we read 0. And the offset was 0, right? So we just return OK. But at that point, we have already modified the buffer length. So that kind of sucks. And that probably means that the file itself should not be modified like this, right? So some tests are going to fail, some tests are going to pass. I think now the large test fails now. That's funny, going back and forth like that. And this reads fucking nothing. A long time from now. Oh. We got trace logging for both. Okay, this is dangerous, right? If I put a buffer in the middle, in between these two things, with no capacity, I think it's going to pass. Well, it didn't pass, but it broke differently. So that's the first write, and then the second write, we do the same. But what's a little scary is that we're going into 0 here, and we should probably go into field. Okay, now all all the tests are failing. So if copy always copies from the beginning of the destination, right? Then that means that we will need like you better take care of your outer buffer, right? After we've done the read. So in this case, we got 496, right? And we read that. The the destination buffer is massive, so we don't care, right? And then we just fill that in. And then we read another 4K, right? And we do the same thing. But the problem is that here we are writing over. We are writing over. Right, because if we have a buffer reader there, then that capacity better be large enough. Like a single read is not going to cut it, right? And that makes sense. So you'll need many reads with that buffer, because the buffer is just for you to do less syscalls, right? You say I have a 4K buffer, then we say, hey, syscall, read all the data you can in here, and then reads all of that. Perfect. If we remove that buffer, right? Now we essentially have a single syscall for reading the entire file. And that does nothing. And I think it does nothing because we're not moving the field amount. So here, right? We're not saying, oh, we have this set this thing to that much. And this read things 3 times, which is, again, not what we wanted. So I did this hack here. So if we read 0, that means that's it. There's nothing more to read. But we don't really set the field amount to 0. I don't know how to do this nicely, though. we're gonna live. It's kind of the same, right? Like, it's really no worries, it's fine. It's really about how we manage the buffer that we're reading into. Like, maybe it really is about. I don't know if we preserve this D though. Like, so we don't really know how much we have, but this is a file, so we should be able to check that, right? Maybe we won't be able to do that. It's funny though that Rust doesn't have anything like that. It's just an own file descriptor, and when we do read vector on here, you just call in read v. what do we get? Oh, King Yolu and Wazak and Senthil. Thanks for the follow, folks. Welcome to the carbon. My favorite thing about OCaml, I think these days, I love algebraic effects. I love how they let you change how the language behaves so much, which can be a bad thing, right? But I think the community is crazy pragmatic in a lot of ways. Very like down to earth, grounded on a lot of things. And of course, I love the full type inference. That that I think full type inference is just game changer. Game changer. No, not quite. We do have monads and things like that, right? Not like Haskell. Much more pragmatic, so closer to how Rust does them in some ways, right? Um, but for example, the thing I'm streaming on is a little project called Riot, and Riot is a scheduler, algebraic effects scheduler for OCaml 5, and it lets you write code with Erlang or Elixir style concurrency. So instead of having like to deal with promises and stuff like that, yeah, exactly. You just go for the act model. Like spawn this function, and this function will run forever until it dies, right? Finishes running this function. And you can send messages and receive and so on. And these primitives allow you to build things where you have thousands of processes, right? And the scheduler just moves them around the cores and everything. Everything happens almost for free, right? There's a small penalty in performance, right? Riot is not optimized for like CPU bound work. Like if you want to crunch numbers and stuff like that, it might be okay depending on how fast you want to crunch them, right? Because OCaml is pretty fast, but it's really better suited for I/O. So reading and writing from sockets, from files, that sort of thing. Cool. Yeah, I hope that I'm embodying the OCaml values, right? If you do want to do CPU bound things, there's this project called Moonpool, which is pretty cool. It's kind of like Riot, but it is defined or like built, designed, right? So that you have less processes, like one per core maybe, and they do a lot of work, like crunching numbers or things like that. In Riot, you are expected to have like I don't know, thousands, millions of processes. So they clearly can't be all of them running on the same CPU all the time, right? They have to switch. But that's great because we have billions of processes, billions. But that's fine because we're mostly waiting on file descriptors and things like that, right? On I/O. Okay, so my guess is that this operation is not modifying the file descriptor the way I thought it would. Which is a bummer. Yeah, There's a couple of things, right, that we're not aiming to do. One sec. Ooh. Thank you so much. Tack så mycket. Yeah, Erlang build. There's a couple of things that we're not trying to do, right? Non-goals. And, we're not going to do a full port of the Erlang VM. There's some things that we just are not considering, right? For example, Erlang or Elixir bytecode, no interrupt there, right? It's just different language. That's fine. No hotcode reloading of live applications because we have a type system and we need to make sure that all of the code, right, is type safe all the time, right? So it becomes really tricky to do this on live applications. Ad hoc distribution, like you say, being able to just run functions anywhere, right? That's something that we're not gonna do at this level, right? I think, in my experience building Erlang systems, distribution is a bad idea. You definitely don't want to do that with those tools. You can do distribution one level above, one layer above, but not at the VM level. And the whole tracing thing is something that I am looking into, but it's not really a goal right now. Hello, this is Leia. No, God damn it. If you can't hot reload, you cannot do type safety. I don't know if maybe you've seen HACKATHON at some point. I'm the author of this, which was a backend for OCaml, right? To to Erlang. So you would write OCaml and actually run it on the Erlang VM. I have code here. It was a lot of fun to do, but it taught me a couple of things. One of those is that it is kind of hard to type Erlang for some reasons. So I'll drop a link here on chat. And this has a couple of reasons why, right? Typing Erlang can be hard. And it has nothing to do with them not being able to build it, right? It's about the constraints, and hotcode reloading is a big part of that, right? Do you feel like the CLM? Yes. I've noticed in a true live environment, I don't miss it as much. Closure is not. So that's not to say that type safety is for everybody. Honestly, I feel like we were talking about this earlier on stream today. I work better with types. My brain just works better with types, right? That is not to say that everybody else's does. Some people thrive in environments where there's no types at all, right? And they build great, large, big systems, complex systems, right? In those environments. I can't. I cannot work that way. I've tried it. I've done a bunch for Erlang. I built a lot of large, complex things in Erlang. And my God, my brain just doesn't work the way. I need to put as much of the cognitive burden of programming and building a system, both programming in the small and in the large, on the computer. I need to do that. If I don't do it, I'm not as efficient a programmer. Leia, you know what you're doing. What's it? Fuera. That's fine. I'm not claiming any absolutes here. I'm just saying building software is hard enough as it is, so pick the tools that make you better at it. And in my experience, I build better software with types. Actually, yeah. I've been coding for a while now. For fun, maybe 20 years. And even though I did a bunch of C and C++ at the beginning, I did a lot of PHP. I I did a lot of work in PHP, in Python, in Ruby, in JavaScript, right? Especially Ruby, and then in Erlang, and then in Elixir as well. Racket, yeah. It's okay. Racket, it's a programmable programming language. I'm sure you can build Elixir in Racket, but with types. All right. And the problem here is that line 18. Leia. Whoa! We got a follow from Blind Nabler. Thank you so much. Thanks. Have a good one, you too. Thanks for stopping by. All right, so the problem is that our file, right? We have no idea where our file is. And we can either add that information ourselves, or we can rely on some behavior for it. And if you go into EIO, right? We have a file, and the file okay, so then I guess we should not. They're not doing that. So when the read is 0, right? They special case this thing. And they return an error saying closed. Or what is it, closed or in a file? In a file. IO result, and I think IO 114 read, and this could be also in a file. And of course, that means the interface, right? Riot MLI read. Leia. 482. This will be f in the file. Cool. So I guess we need to consider that case, which is slightly different than closed. Yes. We might need to consolidate that later, but right now, net reader writer test, right? We have line 27. If we get to end the file or a timeout or the file is closed, we just close. And then line 74, we'll do the same in the file. Leia, não. Leia, o que tá fazendo você? Não pode isso aqui. Sai daqui. Oh. You okay? Yes? So again, 47 in the file. Do test. Line Okay, dumb question, but am I opening the files right? We do open file, right? We have flag lists. Don't think that's a problem. And then when we're going to read B, we actually get the file descriptor under hood. Oh my god. Oh, fuck. I am not resetting the buffer. So this will be the equivalent to writing this Rust program. I'm gonna do 15, right? And I'm gonna use the same buffer everywhere. So what do you think is gonna look, what happen, the results? What do you think they're gonna look like? Will be like this actually. Compile again. There. Fuck. This was working. The problem is that I I need to remember, right, that the buffer, once you read it, right, needs to be emptied. So if we create new buffers on every instance, right, then this might just work. And it fucking worked. Definitely not a fan of, or my brain doesn't work well with this lower level kind of programming. Mutable things, remembering things. See, if I had a type here, or if I could change the type of something in some way, so I read it, and then this goes from being a empty buffer to being a field buffer, then he's like, oh, are you sure you want to read into a field buffer? Sounds like you probably want to get, that buffer cleaned first. So we might want to do something like that, where when you do read, you actually get a buffer back, and that is a buffer, right? It might even share the same everything, but the type will change so that it's okay. This buffer has been filled already, so it's not empty. Ay. And so this is gonna fail. Now, Leia, ¿qué está pasando usted? Test. Maybe that works. And I think that go away. Yeah, that was that. That's how it should behave. I think I have a broken. Yeah, there's a hole in my sweater. That sucks. I think it's important. Cool. So now that we have a test that says here's a big file and you have read it, then I think we're ready to go into Blink again, right? And some of this is gonna blow up because of the interface, I believe. So line 32, it also needs closed, I guess. And it needs end of file. Don't really like that end of file name though. And that's fine because that was the last part. So if we go back into stream, I think this is the best part of already having that interface that we want, right? Because we can just actually make it work instead of trying to read the entire body, which we don't want to do anyways. We can, as we read each one of these chunks, right? We can just push them out into the stream. So we can do a sequence, right? I think all the way up here. But we would want to change something. Because like the problem we have here is that we are using the same buffer, so we overwrite everything. And that makes sense. That's how the buffer works. Not a bug, a feature. So what we want to do is save, right? Immediately after we read, we want to say, like, okay, just put that somewhere else. We want to sync, right? Somewhere to write to. We don't have good syncs yet. So we can do a dumb thing and just do like a reference string here, right? We don't need that. So we do like a frame or data. And we'll do string will be string and data. And this is not how we want to do it, right? But it would be enough. And we can do IO buffer. You know, it would really help if you told me where the fuck is the error. You're not being very helpful at all. Is there no error? Is that what you're trying to say? IO buffer. Come on, seriously, just... What is going on? Link ML. How did that disappear? Makes no sense. Absolutely no sense. And this got duplicated? What in the damn hell? We're missing code here. What the fuck happened? I believe this will actually be the entire website. And it is. So, did you fail? You did. Why? Why did you fail? Show me. Got response that much. I think we can probably get to OCaml org test. Go from debug back to info. Oh, of course. Yeah, because we didn't get an OK. Oh, look at that. And we can maybe assert that the body is like, I don't know, 0. What are you doing? Three, 2, 5 to 2. So I'm not in love with that. So maybe we'll just leave it at OK. Let's actually try with OCaml org. Okay, we're doing something wrong with the certificates, but as far as I'm concerned, some websites seem to work. They don't send a content length back. Are you serious, GitHub? So that's not what I want to do. I want to do option map, right? And here we can do option def value. And we get a default, and that will be 22 and 10. Now, Leia. Okay, folks, we're getting close to the end of the stream. Need debug, and we don't care about that right now. Does that mean that we actually got something? We got an OK from GitHub? Yeah, we get a bunch of headers and stuff. That is pretty cool. GitHub's works. It's not the only one though. Like I really wish that OCaml.org worked, but seems that he doesn't want to play with us. TLS alert. I don't know what that is. But hey, if GitHub works, then I'm happy. I will call it a success for now, for today. And yeah, look at that. Oh, that's not complete though. It does feel a little weird that we don't have a content length on GitHub. Yeah, I guess we don't. But we don't know how much we need to read, so we need to read until we get 0. Right? Right? So NetSocket, no, and NetML. Receive. Yeah, I think we can clean that up a lot. So that took a while. Blink. 178, because the state is that. Let's see what happens. Okay, so eventually we get the entire website according to that, which is great, right? Just wondering why this take that long. Ow. Okay, so that's working, which is great. It's just taking ages. I don't know why. My guess is that either the read loop, right, is just burning too fast here until we actually read 0. But I don't really see the debug calls, right? I mean, it's a bunch of output there, but let's see. Info. Debug. El debugo. This should be obvious. Should be pretty obvious. Like if we're reading like crazy. No. All right. So read React. Then we kind of get stuck there somewhere. Handle TLS? Really? Oh, wait, no. All right, we are inactive. I guess we're right. So that read loop there, it's taking a little bit, just a little bit, right? And I don't know why it's slow, but we're gonna find out. It can be that. It definitely is something happening in here. So come here. I'm gonna go into IO, read. I'm gonna do logger trace. So we are what? Blocked on the socket? That makes no sense. Receive. We are not getting there. No, I think this one has its own logger. Get rid of that. Okay. So we read a lot. Really? Takes so long to actually do that. Seems like there's something wrong here, though. We wait and we retry a lot, right? Which probably means we cannot read anything. Let's ask GPT. Maybe this is some TLS crap. Leia, you're in the way. Leia, god damn it. Move your feet. There you go. We're gonna close that and go to Chat GPT. Hi GPT. GPT is short for Gepetto. Gepetto. GPT. What's this? Is it TLS stuff? All right, I believe you. You sure? Okay. Seems good to me. So maybe there's something wrong about how we're reading, but I'm not sure, right? I'm not sure if the reason that the read is borking out is because we're asking it to read things, right? Here. We can probably also just do reader, buffer reader, right? Of reader, and we'll do no capacity, so we use the default. Same problem. And then eventually, boom. Look at that. Hey, Sabine. Good morning. I don't know. I don't know what it could be. It's definitely not the buffer reading, right? We just enter this state in the socket. It is also possible that we have a bug in here where when we go into the low level module, right, and we do read B, right, this gets in the way. So if we go into Unix here, oh, come on. Interrupted by signal, E again, E would block. We can always look at how EIO does something and learn from them, right? So in the low level, POSIX, ML, FS. I forget where do they have this. Right B. In leave, EIO, POSIX. Low level, yeah. Right? And they have this non-blocking, which is defined right up there. Oh, I think maybe we're doing this wrong. Please, you're Leia. Leia. Hey. This goes there. And we do read B, F, D, CS. Conversation. and then it gets stuck there. Not entirely sure why that is happening yet. But it was not happening. Like, my guess is that because we're doing HTTP here, we actually need to close the connection on our end, right? Based on how much we've read. I just don't know how to detect that, right? And from looking at the headers, and this is going to dump the website in a second. But if it doesn't, if we go to GitHub, right? Then in the first request that we get here, right? We don't actually have the size. I don't know. This is pushing me very, very close down to the protocols. So I need to learn more about how exactly do we terminate, right, a connection. So far, what we were doing was we would loop, right? I can remove some of this stuff. No, actually, I need that. We were looping and passing around an accumulator for the number of bytes that we have read so far, right? And we can actually ask for the string here. So if the string length, right, is bigger or equals than, and we don't know the content length anymore, right? So that kind of sucks. So maybe it would be nice to know what's the last bit of, what is the last read bytes that we get, right? Trace, debug, we go there. So what is this? Is that a termination? That does look very termination-y. Response. Yeah, they're not including it here. So maybe ChatGPT can help us. I am receiving an HTTP response without a content length, but I see this at the end of the body. What is this? Okay, chunk transfer encoding. See, there we got it. But I think that's just a timeout from the server. So it may just be that we need to check, right, if the thing that we just read ends in, right? That, then we're good. So string ends with suffix, right? Oh no, what did I do? Oh my god. in that. Then we're done. And this, what was that? It was this, right? That's pretty good. Cool. All right, so this is definitely not a reading problem, like an I/O problem. This is a protocol problem, which is pretty cool, folks. I think we did it. I think we actually have pretty good I/O inside Riot doing format. We can do buffered reads and writes and stuff like that. We can start with a file and turn it into a reader, and then do buffer reads over it and stuff. And the same thing can be used for sockets. So we can turn a network socket, right, like we do here. Fuck, I don't know where I am. I'm tired. Writer. There you go. So here we can grab a file descriptor that is a socket, stream socket, and we can say, okay, we'll turn it into a writer. So we have a writer that we can write into things into. But more importantly, we can actually wrap this, right, into other writers. So we can create a TLS reader, for example, right? And this did not come out as nicely as I thought it was gonna be. But maybe just because this is not like a generic writer, maybe if this was generic, right, with like a source here, then it would be nice. And I think if that was the case, we would have to define the modules inline. Like we do in Riot, right? Riot lib, and I think we do this in file. No, we do this inside of the buffered one. So it's straight into IO. Just go there. Trust me, I know what I'm doing. Just wrote this code. Buffered. Here, right? Where we say, all right, we say we're gonna have a type for source, right? And we don't really know what that is about. But if you give me a source D, then I'm gonna give you a source D reader, right? And then it does the thing. And this is IO reader T. So 267 source 280, and we'll need to do the same thing for this one. So we'll copy the pattern, actually that to writer. So 294, we don't need to save that. We don't need the socket either. So 293. 348. Yep. So now this becomes an IO reader of TLS, right? Of stream socket. So we managed to build a pipeline, and we can tell exactly what's happening here. Or do we? Can we? I forget. I don't know. I'm tired. Anyways, point is, with or without the shenanigans for the types, we can build a pipeline, right? It's a matter of how we compose the types to actually surface. So this might be a T like that. No, that doesn't work. Doesn't matter. I can read GitHub. Perfect. All right. We won't commit any of this just yet because we want to clean some of this stuff up for sure. It's a little bit garbage code right now. But we have plenty of commits here. So I'll push that into that branch. And we will open a PR on Riot. Compare and pull. Fit, buffered, reader, introduce, reader, writer, and writer, right, interfaces. Draft pull request, that's fine. Yeah, if well-typed witch was still on stream, maybe they are. She'd probably say a module is just a record with existentials, and we'd be like, what? What do you mean by that? But oh my god, 1,000, that's a lot of code. We just added a bunch of code. Yeah. But overall, I'm pretty happy with the abstraction for the users. I think the implementation can definitely use some cleanup. Anyways. That's there. Whew. Winding down now. Similar post now. What the fuck's that? I never want to see that. Do you see this? Such off-center. What the hell? Is that even a margin top? Are you telling me they couldn't do a flex? To do like align content vertically? That looks perfectly aligned. Maybe. Anyways, unimportant. Oh no, nothing like that. It was awesome having you on the stream. All right, folks. Closing down another 15-hour stream. We did a massive detour, but built a pretty amazing reader writer interface pair for Riot that is nicely it composes nicely and should build transformation like I don't want to write a lot. And we got the TLS working on Blink. Okay, nerds, going to bed now. So do tomorrow. And with that, I will say adieu. I am like falling asleep here, like for a little bit already. I need to like squint a little bit or just like get closer to the screen. Or, it is not sustainable to do this, but it's so much fun. And I really want to do as much damage as I can on Riot during this like holiday period. So today's Sunday 24th. I guess Merry Christmas if that's the sort of thing you celebrate. Happy holidays and whatnot. We usually in Argentina celebrate 24th at night, right? And then that's kind of like a party. And then at midnight we open gifts and we just everybody like gets their own. And it's such an amazing tradition like that we have, I think. I grew up enjoying it very, very much. Very nice, fond memories of that time. And then you go to bed at like maybe 3, 4 in the morning, right? Because, it's Latin America. And in the morning after, like I think the best part is the leftovers. Leftover food right there. I get that some cultures do the whole thing where you go to bed early and then you wake up in the morning and in the morning you open the gifts. Like, we got no time for that. They might not be it tomorrow. We may not wake up, so we have to do it tonight. But with that, thanks everyone that's been on the stream. It's been a lot of fun. Hopefully we'll get to build some more things tomorrow a little bit. Definitely less than 14 hours. We have a Christmas to get to. But yeah, I'll see you then tomorrow. Good night, folks. The name is. Yeah, just making fun of Prime now. See you, nerds.